so to give you the picture of how this data platform puts together, we're going to use a scenario of an advertising agency that puts ads in the back of those screens in New York City taxis. If ever you've been in a cab recently in New York, there's an ad that plays and you can interact with it. To give you the picture first, this is a simplified architecture of this data solution. The taxis are sending their position in real time, where they are in the city, as well as their destination, how many passengers they have, and what sort of interactions the customers are doing. PubSub is then ingesting that data. We're using Dataflow to process a data pipeline to handle and process all that data. We're also archiving the entire historical data in BigQuery, which is a really powerful tool for you to do ad hoc analysis of all of your historical data. And at the end, we want to make a visualization. So why don't we actually see the pipeline in action? So this is the Dataflow visualization tool. And you see Robert's hovered. We're ingesting a little over 15,000 new elements per second into this database of all of this information. But how do you visualize all that? Google Maps is super powerful, but I'd hate to point 15,000 updates per second at my Chrome browser. So Dataflow actually allows us to downsample that event stream to give us a real-time visualization of taxi positions. And this is that visualization. This is showing where all these taxis are in New York City at any given time. Now, what if I want to look at one particular customer who's placed ads with us, a particular agency? We can filter that data flow, and now the visualization will update so that we're only seeing ads that are being placed for a specific store. In this case, the Acme store, it looks like, is on the Upper East Side, and sure enough, we see that we're placing ads roughly geographically near the store. But right now, we're just using a dumb rule for this. It's just a very simple rule. Where's the store? Where's the taxi? Place the ads. Can we do better? Can we automate this to start to take into account all the various data that we have about this? Well, let's start by using BigQuery to sort of explore this data set. The query Robert has here looks at all of the taxis coming from the airports and tries to see how many of them are traveling near restaurants. Now, note here, he's querying this historical data even as we're ingesting new data at 15,000 events per second. So BigQuery gives him the ability to have an always up-to-date, real-time view into his data. In this case, we see that roughly 17% of our taxis are from the airport and near a restaurant. Well, that sounds like an insight that maybe we ought to do some ad targeting there. And if you look at this query, you can see it really is a non-trivial query, and BigQuery is handling all that for us. So right now, we are manually configuring these ads. So I think what we want to do is look at a way that we can do this in an automatic fashion. Now, we could similarly search for every different customer, but how do we build a generalizable and flexible model? Well, that sounds like a job for machine learning. Machine learning is tailor-made for taking large chunks of data and building models that give you insights out of that. So we're going to build a model that takes into account all of the data we have. Where did the taxi start? Where did it end? How many people were in it? What time of day is it? Where's it going? First, we're going to start by using, as you see in this picture, we're going to use data prep to take all that historical data, clean it up, make sure that it's ready to use, and then we're going to use it with ML Engine. So this is data prep. The first thing to notice is across the top, data prep has automatically inferred the schema from my table. I didn't have to tell it that. Now, if you look at that passenger count column, you'll notice that it looks a little funny. The histogram up at the top includes some elements where it's like it says there's 10 or 11 people. Now, I don't know about you, but I've been in a New York City cab, and I'm pretty sure you can't actually put 10 or 11 people in a cab. So that's a common data bug. Data prep allows me to fix that in a number of ways. I could delete the data. I could replace the 11 with a 1 on the theory that it's a fat finger mistake. And data prep allows me to build simple recipes that clean up my entire data at scale. It also can do things like, if you look at our location column there, it's a composite column. It's longitude and latitude, comma separated. I'd really like to have a latitude column and a longitude column. Data prep allows me to build a recipe that splits columns with composite data into separate columns so that I now have a better schema to work with. Now, this just scratches the surface of how data prep can take this really tedious job of preparing data for analytics and make it much faster and much more reliable. Once we've done this, machine learning, as you heard from Fei-Fei, allows me to build a model on my laptop, upload it to Google, and deploy it at scale. Let's see how that actually works. If you scroll down in the Dataflow pipeline, you'll see we've added an ML Engine call. So now, as our taxi data is coming in, we're calling to machine learning with the data and saying, help us choose the best ad to target for this particular user. So let's switch back over to the map with the deployed machine learning model. And now you'll see that we start seeing some interesting combinations. When there's one passenger coming in towards Midtown, the taxi's currently in Chelsea and it's on its way to Midtown, we're presenting an offer for Manhattan Bagels because it's a single person, maybe he or she wants a bite to eat. If we pick a taxi that has more than one person in it, if you have a taxi with more than one person in it, there it is. In this case, that's still not. That's a one-person one, but they're heading into a different location, and instead we've chosen a winery. If you pick a taxi with 3 people, the system would automatically recommend discounted tickets to Broadway, for example, as multiple people coming to Midtown in the evening. So that's Cloud ML making suggestions based on all our available data. We used PubSub to ingest a huge stream of data at scale. We used Dataflow to build a pipeline to give us a good analytics system. We used BigQuery so that we always had the complete historical data available. We never had to deal with sampled data. And at the end, we used Cloud ML and data prep to build and train at scale a model. What's important here is what you didn't see. I didn't deploy a virtual machine. I didn't deploy patches. I spent my time actually in the data. That's the point of big data, is to spend the time in the data, not in the machines that take care of the data. And that's what big data on the Google platform does. So I want to thank you all, and I'll turn it back over to Brian.